My dear students of Btech second year, I am Dr. Rohin Parsai, Associate Professor of Mathematics in Engineering Science Humanity Department at Chamli Devi Group of Institution Indore. I wish to teach you through Lecture 4 as an introduction of finite differences and with examples. So suppose that we are given the following values of y equal to fx for a set of values of x. Say x for this first value is x0, second value is x1, x2 and so on up to xn, and their corresponding values of y to be y0, y1, y2 and so on up to yn. That is, suppose that the function y equal to fx is tabulated for the equally spaced values x equal to x0, x1 as x0 plus h, x2 as x0 plus 2h and so on up to xn equal to x0 plus nh, giving for their corresponding values are to be obtained by using this relation as y equal to y0 for x0 and for x equal to x1 the corresponding value of y is y1, y2 and so on up to yn, where h is called a common difference. We define the following two types of finite differences as we can guess the operators, that is forward difference and the backward difference. So first we concentrate on forward difference. The first order forward difference are defined and is denoted by delta of fx equal to x plus h minus f of x, denoted by Greek letters delta. That is, we will say corresponding to these values as corresponding to the entries. So the values of dependent variables are known as entries, while the value of x are known as arguments. So first order difference is calculate for this y0 is y1 minus y0. For the next entries we will calculate the forward difference as y2 minus y1 and so on. You can continue for delta of y2 as y3 minus y2 and so on. For our entries we can define this first order forward difference by y of r plus 1 minus y of r, and that is you can generalize as y of n minus 1 equal to suffix mein you are adding plus 1 and this side you have to subtract this yn minus 1. So these are called the first order differences and delta is called forward difference operator. Similarly, the second forward difference is defined by delta 2. It is denoted by delta 2 of y of r equal to delta of y of r plus 1 minus delta of yr. In general, for pth order forward difference is defined as p raised to p minus 1 r plus 1 minus del of p minus 1 of yr is called pth forward differences. The forward difference systematically set out in a table called forward difference table. So we can represent this all the various order of forward difference in the tabular form. Suppose we are having x0, x1, x2, x3, x4, x5, that is 1, 2, 3, 4, 5, 6. Suppose you are having x as independent values which you called as arguments. First you are having the column of, you always take the first column whenever you prepare a difference table. First column you will take independent variable values, or we can say in finite difference language as argument, and while second column is of entries, that is the corresponding value of dependent variable as we say y0, y1, y2, y3. y4, y5. Now for finding the first order, all possible forward difference is very simple. Subtract y1 minus y0, y2 minus y1, y3 minus y2, y4 minus y3, y5 minus y4. This gives you first order forward differences, and when you continue again these differences successfully, you will get second difference, third difference, fourth difference and fifth difference. How long you will continue? As long as you not get a single difference here. So in this way we can calculate the forward difference for a given set of values. Now we concentrate the another difference operator is known as backward difference operator. The first order backward difference are defined and is denoted by lambda, Greek letter lambda, f of x equal to f of x minus f of x minus h. That is, we are saying that in terms of y1, y2, y3, y0, in this way delta y1 equal to y1 minus y0. Then second, that is the first backward difference for next entry, then for y3, then and so on for y of r. We define is backward difference by yr minus 1. How can we write this? You will find very easily. First term having 3, then second term having 2. That is, if it is r, then this subscript is r minus 1. So yn having n, so here you having n minus 1. So these are called first backward differences, and lambda is called the backward difference operator. Similarly, the second backward difference is calculated similarly by continuing the same process here, lambda of yr minus lambda of yr minus 1. In general, delta p of yr equal to delta p of p minus 1 of yr minus delta p minus 1 of yr minus 1 is called pth backward differences. So the backward differences systematically set out in a tabular called backward difference tables. So that is, we can show all these backward differences by through this table, so that it is called the backward difference table. It is called the value of lambda of y1, it is the value of difference of this and this is called lambda of y2, lambda of y3, lambda of y4, lambda of y5, and so on. You can continue. When you continue this process second time, it is called second difference, backward difference, third backward difference, fourth backward difference, and the fifth backward difference. As long as you will not get only one value, you will continue this. Let us we concentrate some example on these operators as finite difference operators. So these are the examples from the, we are using only the concept here. So our this problem is related to forward difference operator because delta is available. That's why we know the concept of forward difference operator is delta of fx equal to f of x plus h minus f of x. Let us apply for this first function is fx equal to tan inverse x. So value of function increased by h minus original value of the function. Then you can apply the trigonometrical formula. Tan inverse of a plus b is equal to tan inverse of a minus a plus b upon this 1 plus a plus of this. Tan inverse a minus tan inverse b is tan inverse a minus tan inverse b is tan inverse of a minus b upon 1 plus a into b. So the result is tan inverse h upon plus minus x से cancel हो गया. Simply this gives to you 1 plus hx plus x square is in the denominators. So this is the value here. Now you concentrate similarly the second examples. So value of function increased by h, where you are having x, put x plus h everywhere. So e raised to x plus h log of 2 of x plus h minus e raised to x log of 2. Then e raised to x plus h log of 2 of x plus h is as it is. I am adding and subtracting this value so that we can write in symmetrical manners. So e raised to x plus h log of 2x plus e raised to x plus h log of 2x minus of e raised to x of log of 2x, so that you can take e raised to x plus h common and you can apply the logarithmic formula as log m minus log x, log m upon log n. So log of x plus h upon x, so 2 से 2 कट जाएगा आपका, simply you will get x plus h upon x, and here you can also write the remaining terms whatever may be the remains here, as by taking log of 2x is common, to e raised to x plus 2x plus h minus e raised to x in another terms, or we can take thoroughly e raised to x is common, and you can write this by separating this log of 1 plus 1 h upon x plus e raised to h minus 1 of log of 2x. Similarly, you can try these second problems at your home by applying the same concept. By using this trigonometrical identity, cos c minus cos d equal to 2 into sine of c plus d upon 2 into sine of d minus c to here. So you will get these values after substitution of this. So sine hyperbolic h minus 2 is common, whatever may be the remains here, sine of 2x plus 3h minus sine of 2x plus h inside the second terms here. Again applying these formulas, to further you can simplify this by using this identity. So this can be written as, just by final multiplying this, 2 2s are 4 minus 4 sine h square hyperbolic h and cos of 2 taken common x plus h. Similarly, you can try the second example. Just the difference is you will have to take the common difference as 1, as h equal to 1 is the 1 as the interval of differencing. So from the definition of forward difference here, again using the concept here, delta of f of x equal to f of x plus h minus f x, as h equal to 1 you have to take. So you start here having f of b of x plus 1 minus b raised to x. Just by taking b raised to x common, this gives to you b minus 1. Therefore, the value of second time when you repeat this, when you apply the answer in first time, just you are applying to here. So what is the value of first difference, forward difference here? A b raised to x into b minus 1. So applying this, as by taking the constant outside this forward difference operator, because it is a scalar with respect to the function, so b raised to x having only function of x, so written function values you will take outside this forward difference here. So simply this gives to you a into b minus 1 of b raised to x plus 1 minus b of x. So this again you will take b raised to x common from this, you will get b minus 1 whole square into a of b raised to x. Now you go for the next example here, e raised to x, applying over this x plus 1 minus e raised to x taken common, e minus 1. So this is the value in first time. When you repeat second time, you will get e minus 1 whole square in here. E minus 1 whole square e raised to x. Therefore, you can continue this process. Similarly, for third time, you will get the power of e minus 1 is 3, e raised to x is constant, common multiple here function, and so on. You can continue for n times difference. You can write by symmetry. The answer is e minus 1 raised to n of e raised to x. Thank you very much.